and it results in massive reorganization of the embryo. Okay? From a single spherical ball of cells into a multi-layered organism. Okay? So many of the cells at the surface along the ectoderm are going to move deeper and form endoderm or mesoderm. The cells that remain are going to give rise to the ectoderm. Okay? The endoderm, the most internal of the germ layers, is going to form the lining of the gut, the GI tract, and other internal organs like the respiratory tract or the collecting system of the kidneys. The ectoderm, we said because it's on the surface, is going to form the skin, but it's also going to contribute to the formation of the brain and spinal cord. In other words, the nervous system. And the mesoderm, or mesoderm, the middle layer, is going to give rise to muscle, bone, and parts of the circulatory system. So now this is a distant view of this gastronome. And you can see the ectoderm, the mesoderm, and the endoderm is now surrounding the yolk sac. Here, the mesoderm, the cells of the mesoderm have begun to divide and migrate along that connecting stalk. They're forming an umbilical cord. Okay? Here, we see the cells of the cytotrophoblast forming these little villi. In gray here is the syncytial trophoblast, which is expanding further into the endometrium, and as it does so, it is eroding into maternal blood vessels. So you see pools of maternal blood here. Now remember, by this point, this is 2 weeks following fertilization, this structure has elongated. It looks more like this. And here's that amniotic cavity. Here's the yolk sac. So you have to kind of connect or correlate the cross-section with the three-dimensional structure. Of course, this is further along. This is at 21 days compared to the 14 days. Okay. Neurorelation refers to the formation of the nervous system, specifically the brain and the spinal cord. Think of this layer of cells here as the ectoderm. Okay? So what happens during week 4 is this, is that the edges of the ectoderm begin to come together like this. And as they do so, what happens? The central portion of the ectoderm invaginates in. And as it invaginates in, it forms a tube. Okay, just like I've shown here. Here's the ectoderm. It's coming together. It's forming a tube here. And this tube is the primitive nervous system. Okay. We call it a neural tube, but it's the precursor to the brain and spinal cord. So you can see that the brain and the spinal cord are going to evolve from the ectoderm. Okay? Now, in red here was the mesoderm. Okay? By the 4th week, the cells of the mesoderm have begun to differentiate into structures. Okay? This structure that sits just beneath the neural tube is called the notochord. The notochord is the early vertebral column that provides support for this elongated structure. Okay, so that's the notochord. And then what you see here, these segments on either side of the notochord are called somites. These are segments of muscle tissue that will give rise to muscle. So you can see that the mesoderm is going to give rise to bone and muscle. The endoderm here, right now it's surrounding the yolk sac, but eventually part of that yolk sac is going to contribute to the GI tract. Okay, so you can see the endoderm is going to give rise to the lining of the GI tract. Now, we don't have a class in embryology here that will go through these steps in painstaking detail. But if any of you are planning to apply to medical school, one of the tests you have to take is the MCAT. I just spoke to a few of our students who took the MCAT, and they mentioned the embryology. And the main questions that deal with embryology are questions about the germ layers. Which germ layers give rise to which structures? So you have to know that ectoderm gives rise to skin and nervous tissue. That mesoderm gives rise to muscle, gives rise to bone, and connective tissue. And then the endoderm gives rise to the lining, particularly the epithelial lining of the GI tract, or the respiratory tract, or the urinary tract. And this just shows that process of neurorelation, how the edges of the ectoderm kind of migrate toward each other, and in doing so, form this tubular structure called the neural tube. This is occurring in the first month of pregnancy. Okay? So one of the problems that a pregnant woman can develop during that first month is what are called neural tube defects. In fact, one of the reasons that pregnant women have to take folic acid as a supplement during pregnancy is to prevent neural tube defects, okay? Where this neural tube becomes fully formed. If it doesn't become fully formed, it can remain open. This primitive neural tube can remain open to the outside. For instance, this baby here has a neural tube defect. And the filaments inside of cells that allow for cellular movement, many of these filaments are called actin filaments. And the way this formation occurs is that the actin that's along the apical surface of the cells contracts, so that the cell, instead of becoming cuboidal or columnar, it begins to do this. And as all the cells change shape, this invagination begins to form, leading to the neural tube formation. So here's a baby born with a neural tube deficit. So your germ layers. Your germ layers are going to give rise to those four primary tissue types, which are epithelium, connective tissue, muscular tissue, and nerve tissue. Epithelium can be derived from all three germ layers. For instance, the covering of the skin, the epidermis, it's stratified squamous epithelium. That's an epithelium. That's derived from ectoderm. There's some components, a few components of the epithelium, particularly that within the kidney, that are derived from mesoderm. And then the lining of the GI tract and respiratory tract are derived from endoderm. For instance, the GI tract from the stomach on down is lined by a simple columnar epithelium. Well, that epithelium is derived from endoderm. Connective tissue comes mostly from mesoderm. We said muscle comes from mesoderm, and nervous tissue comes from ectoderm. So this development from germ layers, which are loosely organized tissues, into more differentiated tissue occurs during the first 4 weeks of life. So the mesoderm, that middle layer, is going to give rise to almost all the connective tissue in the body. And when we talk about connective tissue, we like to differentiate embryonic connective tissue from adult connective tissue. Most of that connective tissue that forms early on is a form of embryonic connective tissue called mesenchyme or mesenchyme. Okay? Now that mesenchyme, okay, which again is formed from mesoderm, is going to give rise to various types of adult connective tissue, including blood. That mesenchyme is going to give rise to muscle and blood vessels and structures within the kidneys. There's a second type of embryonic connective tissue, and that's called mucus connective tissue. It is found only within the umbilical cord. It's a gel-like structure that surrounds the vessels, the three vessels that are found in the umbilical cord. So some people refer to this mucus connective tissue as Martin's jelly. So again, there are two types of embryonic connective tissue, mesenchyme and mucus connective tissue. Most adultive connective tissue is derived from mesenchyme, embryonic connective tissue. So you hear, Mesoderm gives rise to mesenchymal cells or mesenchyme. And mesenchyme, you can see, is giving rise to all of these different types of cells that are part of adult connective tissue. Fibroblasts are part of fibrous connective tissue. Adipocytes are part of fat or adipose tissue. Chondrogenic cells like chondroblasts and chondrocytes are part of cartilage. Osteoprogenitor cells are part of bone. Mesoderms can also give rise to hematopoietic stem cells, cells that are part of blood. This is what mesenchyme looks like. These are spindle-shaped cells that kind of reach out and touch each other, forming a network. Okay? Again, mesenchyme is found primarily in the embryo, although there are little pockets of mesenchyme even in adults. Okay? So these are spindle-shaped cells that have long cell processes that reach out and touch each other. Okay? The stuff in between, the extracellular matrix of mesenchyme, is a viscous ground substance, means it's thick. There are very few fibers, reticular fibers, and reticular fibers really can't be well seen by a microscope, so you don't see a lot of fibers between these cell processes. Okay? This is important. Adult connective tissue retains some mesenchymal cells that act as a source of repair when necessary. So if I show you, and later we'll look at images through an embryo, that connective tissue you see is mesenchyme. Mucus connective tissue, on the other hand, to me resembles cotton. Okay? Again, it's found only in the umbilical cord. The cells are also kind of spindle-shaped, meaning elongated. Okay? And the space between cells are formed in large part by these wispy collagen fibrils that give the tissue kind of a cotton-like appearance. There are a few fibroblasts also present. These are mucus connective tissue cells here. Let's talk about the concept of a stem cell. And I think we may have talked about stem cells in A&P. But a stem cell is simply a cell that is very active mitotically, meaning it undergoes recurrent cell division. And of course, when cells undergo cell division, they form two daughter cells. So here's your stem cell. It's going to, when it divides, it's going to form two daughter cells. And we'll call one of these cell A, the other one will be daughter cell B. Now, with stem cell division, one group of cells, these A cells, simply serve to replace the parent. They continue to divide actively. The type B cell not only divides, but it acts as a progenitor cell, meaning that it's going to begin to differentiate at some point along one or more lines. Okay? Now, if it only differentiates along a single line, we say that it's a unipotent stem cell. It can only form one type of progeny. But some stem cells give rise to multiple cell lines. C, D, B, and you can have multiple different cells that can be derived from the early progenitor cells. Those are called multipotent stem cells. Okay? So the term for the type of stem cell depends upon how many different cell lines that progenitor cell can give rise to. Whether it's unipotent, multipotent, or we'll call it, later we'll talk about pluripotent and totipotent stem cells. We like to collect stem cells from the umbilical cord for future use. Because if a child, for instance, develops a problem further down, we can manipulate those stem cells to give rise to different types of tissue. So this is just showing you that here's the original stem cell. Here's its daughter cells, which are going to form either a type A cell or a type B cell. And a type B cell, the progenitor cell, is going to ultimately give rise to more fully differentiated cells. Okay. So the terminology here. A totipotent stem cell is able to give rise to all cells within the embryo and adult. Okay. So only the fertilized egg, the zygote, and the early blastomeres are truly totipotent. Okay? If you take those cells, you can eventually manipulate them to form a complete organism, because they give rise to all the different cells within the developing embryo. A pluripotent stem cell, okay. By the way, totipotent can give rise to the extraembryonic tissues, the placenta. Pluripotent are capable of giving rise to all the cell types within the embryo and adult, but not to the placenta. Okay, so those cells from the inner cell mass would be considered pluripotent. Multipotent stem cells can differentiate into multiple cell types, but only those of closely related cells. So for instance, the stem cells that exist in the bone marrow, called hematopoietic stem cells, they can give rise to all of the cell types present within the blood. A unipotent stem cell can only produce one type of differentiated cell. For instance, the cells that along the basal layer of the epidermis, these epidermal stem cells, they can only give rise to keratinocytes. So those would be unipotent. So if we take cells from the inner cell mass, we can manipulate those cells to give rise to the tissues that make up the circulatory system, the nervous tissue, the immune system, because these are pluripotent. They can give rise to any cells within the embryo or adult. What I'm showing here is the process of in-vitro fertilization. Okay, how does in-vitro fertilization work? So what you do is you provide hormonal stimulation to the female to get the oocytes to mature in follicles. Okay? Then you harvest some of those follicles, okay, collecting the oocytes from the follicles using like a turkey baster, taking some type of suction device. And you put them in a petri dish. So you harvest the oocytes from the maturing follicles that have been stimulated by hormones. And in the petri dish, you mix them with spermatozoa, capacitated sperm that are ready to fertilize. Okay? And so you form early zygotes, which are beginning to undergo cleavage. Okay? At this stage, during the cleavage stage, you can take some of these structures and inject them into the uterine cavity, because you're taking them in a stage where they're forming now blastocysts. And by nature, these blastocysts are going to want to implant, as long as you've prepared the endometrium hormonally. So you have to do it during the right part of the cycle. Okay. How many of you, were all able to follow those things that I talked about today? Okay. Now, let me say this. This is simply a lead-in. What we talked about to this point here was simply a lead-in to histology. Histology is really the study of tissue. We're going to look under a microscope at the various tissues. But it's important just to recognize where this tissue is coming from. Okay, how it's formed. So that if I say, well, nervous tissue is derived from ectoderm, you understand why that's the case. Now, I'll say this, is that it would be great if we had a course here in embryology. Embryology is really tough because in your mind, you have to take two-dimensional figures and create a three-dimensional image. It's a painstaking course. Nobody likes embryology, but everybody likes having taken it because it provides depth of understanding. Okay. Start like on. So, let me just ask, let's take a little bit of break and let me ask you some questions. Y'all are excited to be back in class?
Yeah.
How was the end of last semester learning online? Was that a good thing? Was it a bad thing?
It was bad.
Didn't enjoy it as much. No. I think that all of the private universities are suffering some right now. Number one is, what you find is most students don't like to take online courses. Secondly, for private universities, we've lost a little bit of enrollment because students will say, well, gee, if the courses are online, what's the benefit of coming to a small school? And so some of our students have at least temporarily transferred to like Elgato or UNO, where they're taking courses online, but at least it's at a lower tuition. So I'm glad at least we're able to have some courses in class this semester. Mostly it's going to be clinical classes, science classes. Now I know that many of you are in the cardiorespiratory class. Are y'all taking any other physical class? Well, the NT people will be. Anybody else taking any other physical classes? Oh, so the organic lab is going to be, oh good. I know they got a lot of new equipment in that lab. I have to say this, is that the chemistry teachers here are very, very good. Have y'all had Dr. Adams and Dr. Beavers yet? We've taken a department that used to be a weakness, chemistry. People used to hate chemistry here because we just didn't have great teachers in chemistry.